Hello, viewers. In today's class, we are going to discuss yet another important and very conceptual problem from integral inequalities. Right? So, in this class, we'll solve this problem where we have 0 to 1 e raised to 2x cos x dx is less than or equal to p times sine. Here we have the hyperbolic sign. So, we have hyperbolic sign of q. We have to find e raised to pq where p and q are greater than 0, right? So here we are given an integral inequality in which this integral, that is 0 to 1 e raised to 2x cos x dx, is less than or equal to p times the hyperbolic sign of q. Then we have to find the value of this expression, that is e raised to p times q where p and q are greater than 0, right? So let us start. So here we are going to find the application of one important integral inequality, which says that if we have two functions, say f of x and g of x, right? Suppose we have two functions f of x and g of x, and f of x is greater than or equal to g of x in the interval, that is x greater than or equal to a but less than or equal to b, then the area bounded by this function f of x within this limit, that is a to b, is always greater than or equal to the area bounded by this function or this curve g of x between these 2 points a and b, right? So then we can write the integral a to b f of x dx should be greater than or equal to the integral a to b g of x dx, right? So in our earlier video we have already explained this inequality in detail, right? So here we are going to use this concept to solve this problem. So let us take this integral as I, right? So here we have I is equal to 0 to 1 e raised to 2x times cosine of x dx, right? So now this inequality reads as I less than or equal to p times the hyperbolic sign of q, right? So now we are given this inequality, and with the help of this result we have to find the values of p and q, and then we can find out the value of this expression, that is e raised to p times q. So now let us start with this function, that is the cos of x. So we know that in trigonometry, cos of x is less than or equal to 1 whenever x belongs to the interval 0 to 1, right? So here we'll start with this inequality, that is cosine of x is less than or equal to 1. Now see here we have this term e raised to 2x associated with cosine of x, right? So to get e raised to 2x with cosine of x, what we will do, we'll multiply this inequality throughout by e raised to 2x without disturbing the direction of the inequality. Why? Because we know that the exponential function is always greater than 0 for all x belonging to the set of real numbers, right? So e raised to 2x is always a positive quantity for all values of x belonging to the set of real numbers. So what we will do, we'll multiply cos x and 1 by e raised to 2x so that we can get this term, right? So we have now e raised to 2x cos x, and here we have 1 times e raised to 2x, so this is e raised to 2x, right? So now we have obtained an inequality which is similar to this one, right? So whenever we encounter these type of problems, our first aim is to get an inequality which is similar to this one, that is f of x is greater than or equal to g of x, or in other words we can say that we have to form, or we have to frame an inequality which gives us the function f of x and g of x, right? So what we will do, we'll now take this e raised to 2x as f of x, and e raised to 2x times cosine x as g of x, right? So now see what we will get. Here we have g of x, and now this is less than or equal to f of x, right? So we can also write this inequality as f of x greater than or equal to g of x in the interval 0 to 1. So a is 0, b is 1, right? So a is 0 and b is 1. So we have obtained e raised to 2x cosine x is less than or equal to e raised to 2x, or in other words we can also write it as e raised to 2x is greater than or equal to e raised to 2x cos of x, right? So e raised to 2x cos x is gx, and e raised to 2x is f of x. So we have f of x greater than or equal to g of x, right? So whenever we come across with these type of problems, our first aim is to form or get an inequality which is similar to this one, so that we can assign, or we can take the function f of x and g of x out of the inequality. So now we have fx greater than or equal to g of x. So we can now apply this inequality, that is integral of f of x from a to b. So here we have a 0, b is 1. So we have 0 to 1 f of x dx should be greater than or equal to 0 to 1 g of x dx, right? Now f of x is e raised to 2x. So we can now write 0 to 1 e raised to 2x dx greater than or equal to 0 to 1. G of x is e raised to 2x cos x, right? And now this integral is I. So for simplicity we can now write the integral, this integral can be denoted by I. So we have 0 to 1 e raised to 2x dx is greater than or equal to I, right? So we can write now I, this is less than or equal to 0 to 1 e raised to 2x dx. So I is now e raised to 2x over 2, and the limits of integration are from 0 to 1. The integral of e raised to 2x is e raised to 2x divided by 2. So now we can write I less than or equal to, here we have half, taking half outside and then substituting the limits. So we have e raised to 2 times 1 is e square minus, and taking x is equal to 0, here we have e raised to 0, right? So I is less than or equal to half e square minus 1, because e raised to 0 is equal to 1, right? So now we have obtained another important result, that is this integral, that is 0 to 1 e raised to 2x cos x dx is less than or equal to a half e square minus 1, right? So this is another important result related to this integral. But in this problem, we have to express this result in this form, that is p times the hyperbolic sine of q, right? So here we'll use the definition, that is hyperbolic sine of x is given by e raised to x minus e raised to minus x over 2, right? So this is the definition of a hyperbolic function of sine of x. So here if we take x is equal to 1, what we will get, sine, here we have sine h1, that is hyperbolic sine of 1, that is e raised to 1 minus e raised to minus 1 over 2. So this is e minus 1 over e divided by 2. So e square minus 1 over 2e, right? So hyperbolic sine of 1 is equal to e square minus 1 over 2e. So now what we will do, we'll take this e to this side, right? So e times the hyperbolic sine of 1 is equal to half times e square minus 1, right? So now we can substitute the value of half e square minus 1 in this relation, right? So now this relation becomes, if we replace this integral by I, we can write I less than or equal to half e square minus 1, which is equal to this expression, that is e times hyperbolic sine of 1, right? And see, here we are given that this integral I is less than or equal to p times the hyperbolic sine of q. So now if we compare these two results, then we can easily see that P is equal to E and Q is equal to 1, right? This is a very important problem. P is equal to E and Q is equal to 1, and P and Q are obviously greater than 0. E and 1 are greater than 0, right? And we have to find the value of E raised to PQ, right? So P is E. So we have E raised to E times 1, that is E raised to E, right? So this is how we can find out the value of this expression using this integral inequality, right? So viewers, by making use of this important integral inequality, we can solve these kind of problems.